Today we're going to look at inequalities in triangles. So there's two theorems that we're going to start with, and it's the longer side theorem. Just means that if the angle is across from the longer side, it's going to be a bigger angle. So in this diagram here, we see that AB is 8 and BC is 5. And since 8 is across from angle C, that means angle C, this measure will be bigger than angle A right here, because A is across from the length 5 and C is across from the length 8. So longer that it's across from, the bigger the angle. And then the same goes in the opposite direction. If it's a bigger angle, it means it's going to be a longer side. So in this case, this number here, the length of BC, it's going to be longer than the length of AB because it's across from a larger angle. So we can use that then to write some inequalities and to talk about lengths of sides and how we can use that. So this problem says you're constructing a stage prop that shows a large triangular mountain. The bottom edge of the mountain is 32. Okay, the left slope is 24 and the right slope is 26. And it says to list the angles of triangle JKL in order from smallest to largest. Well, we want to look at first the smallest side and say, okay, that's across from angle L, so angle L is the smallest. Then the next smallest side is across from angle J, so angle J is the next smallest. And then angle K is across from the largest side, so it's going to be the largest angle. Okay, so we can do that again in the opposite direction, and we can, or I'm sorry, with sides that are already labeled, and so we're looking at what they're across from. Okay, so the smallest is 5.9, and that's across from angle Q, so angle Q is the smallest angle. 6.1 is the next smallest, which is across from angle P, which is the next smallest angle. And 6.8 is across from angle R, which is the next. Okay, so the order from smallest to largest is QPR. All right, and then you can use the angles to do the same thing and list the sides from length to shortest to longest. So again, the smallest angle is across from that side right there, which is ST. So ST is our shortest side. And then 30 degrees is across from RS. And then 121 degrees is across from RT. And RT is going to be our longest side because it's across from the largest angle. So we can also use that then to kind of think about triangles and say, okay, we have this triangle. Oh, goodness. Okay. And one side of this triangle is going to be 14. One side is going to be 9. What is the possible length for this other side? What could it be? Okay. So I want you to think about, could it be 14 and 9 together? Could it be longer than 23, or could it be 23? Or if 14 and 9, the difference is 5, so could it be shorter than 5? Would that be able to connect the triangle? So really, that x has to be greater than 20, or sorry, oh goodness, greater than 5 and less than 23. Okay? Goodness, sorry, there you go, update. Okay, so that's called the triangle inequality theorem. And that just says that if you add the two sides of a triangle together, the third side can't be longer than that. And if you subtract the two sides, that difference, the other side can't be shorter than that. Okay? So we'll do some practice with that. So if we have a triangle and one side is 12 inches and one side is 20, the possible lengths of the third side, so we'll call this y. So y can be 12 and 20 added together, okay, is 32, and 20 minus 12 is 8. So y has to be greater than 8 and less than 32, okay? Otherwise, it is not possible for that to be a triangle. All right, so then we can also use that to decide if these are reasonable lengths for side lengths of a triangle. So what we want to do is say, okay, we're going to add all the combinations of the two sides together. So 4 plus 9, 9 plus 10, and 10 plus 4. And what it equals needs to be greater than the side that's left. So 4 plus 9 is 13, and that's greater than 10, because that's the side that's not being added there. 9 plus 10 is greater than 4, okay? And then 10 plus 4 is 14, which is greater than 9. So yes, all the sums are greater than the other side. Okay, so we can try this one. So we do 8 plus 9, 9 plus 18, and 8 plus 18. Okay, so 8 plus 9 is 17, 9 plus 18 is 27, and 8 plus 18 is 26. Okay, so these two work, but this one does not, because 17 is less than 18. So these cannot be a triangle because 17 is less than 18. So when you do all three sets of sides, they all need to be greater than that other side. And because 8 plus 9 is not greater than 18, that cannot form a triangle. Okay, so let's try this one. We have 5 plus 7, 7 plus 12, and 5 plus 12. So this is 12. This one is 19, and this one is 17. And this one's tricky because 12 is equal to 12. Okay, but you can see, like, if we scroll up here and look, these are not greater than or equal to. Okay, it has to be greater than. Okay, and 12 is not greater than 12. So the answer to this one is no as well. So again, we can go back here and look at this. These are all greater than. When you add these two sides together, it has to be greater than that third side. Otherwise, it cannot create a triangle. Okay, it is not possible. But again, you have to be careful. It's not greater than or equal to. It has to be bigger. Okay, so 5 plus 7 is not bigger than 12, so that does not create a triangle. Okay, now we're going to use what we've looked at and what we've learned and answer some questions. So it says PR and PS are equal. We can see here that PQ is part of both triangles. And it tells us that the measure of QPR, so this angle here, is greater than the angle here. So we want to know what's longer, SQ or RQ. Well, since they have two side lengths that are the same, but we know that the angle that's across from this remaining side length is larger, then we know that RQ is going to be longer. Okay, and that's because that angle's bigger and the other two sides are the same. All right, so then we're going to look at this one, and it says if PR is equal to PS and the side length of RQ is less than the side length of SQ, we want to know which angle is bigger up here. So this one is shorter and this one is longer. So that means that this angle is going to be smaller and this one's going to be larger. So we know that angle SPQ is larger. Okay? All right. I would like you to pause your video and try these two questions on your own. So again, pause the video, try to answer these, and then I'll go through them. Okay, so if we're listing the angles in the triangle from largest to smallest, you have to pay attention. This time we're listing the largest one first. I need to look at the side lengths, and I see that the largest side is 25, and that's across from angle A. Okay, the next side length, the next longest side length is 20, which is across from angle T. And then the shortest side is across from angle B. So angle B is the smallest angle. Okay, and then this one is, can a triangle have these lengths? Okay, so that's where you're going to do 6 plus 10, 10 plus 17, and 6 plus 17. So we get 26, or I'm sorry, 16, I can add, I promise, and 27 and 23. Okay, so again, these two work, but all three of them have to work, and this one does not, because 16 is not longer than 17. So the answer to this would be no, there is not a triangle with those side lengths, because 16 is not longer than 17, and that must be true.